Hello, everybody. Welcome to this last session of this workshop series, Virtual Reflections. I call it Virtual Reflections because we would be finally start working with the webcam or any camera that you can plug into your computer to create visuals based on the webcam input. And that there's a lot of artists that work with that, but in particular, I'm going to show you one artist who's been doing really dedicated his life, like decades of life, to create a lot of different kind of mirrors. So one of his most famous one, which is currently installed at sort of the entrance of the ITP program, is called a wooden mirror. Essentially, it's a mirror that consists of a small tile of wood panels, and as the viewer pass by or look into the mirror, then the viewer's image are reflected based on how much, based on sort of the lighting and shadow, like how much each wood panel moves and tilts. And then he has a lot of, that's one example, but he has a lot of amazing mirrors. There are software mirrors. There are the one that created with the trash mirror, and again, based on the movements. There are ones that created with like different toys, or really a lot of pom-pom mirror, penguin mirror, like a lot of different mirrors. I really highly recommend checking out his work, and I drew a lot of inspiration from that. I personally actually also really fascinated by the idea of pitfalls and mirrors. So I use this idea a lot in my own work. I'll share the link in the chat in case you want to check out Daniel Rosen's work. And also, I believe I have a YouTube video that discussed all his mirrors. I'm also going to share that in the chat. Maybe just a quick overview for the YouTube viewers. It's this video from Wired, how this guy makes amazing mechanical mirrors. So mirrors like these. Oops. So making the wooden panels like this mirrors. Yeah. So really just to give you a sneak peek. I'm not sure how much I can record and post on YouTube. So I'm really just going to show you some short clips, and then you can check it out later from the YouTube link. And then one work that's literally inspired by Daniel Rosen, just as sort of a test, a proof of concept, is I create like a virtual 3D mirror with like that's similar to the wooden mirror that created by Daniel. And another example would be this is one other work which is a variation of a Mandarinizer, which is a virtual mirror that converts image to Mandarin Chinese characters. So as I move, it also changes, the part that moves also changes colors. And there's another variation that stays static until I moves. So these are the type of thing that you can create. And then we also have the scribble mirror that one of you mentioned before, where I move around, the whole image is formed by scribbles, and there are actually, I believe, 4. Yeah, if I remember correctly, I think four. I think actually this one particular one might be 3, just a CMY. So cyan, magenta, and yellow, 3 colors. So the sort of scribbles are only in those 3 colors, but by combining them, you see all different colors of me. And for today, what we will be creating is this one. And let's see how far we're going to get within 2 hours. So this very similar idea, but I sort of simplify it so that each pixel is a small rectangle that moves around, that sort of shrinks and expands. So let's get started by creating a new sketch. And new sketch. So far we've been creating different visuals, creating images, but we haven't, but what if you have a photograph or a picture that you want to load into the sketch? In order to do that, we are going to click on this button that we never really used so far. If you click on this, you'll see that what we've been working with is this file called sketch.js, which is a text file that's we've been editing. But there's also 2 more files, HTML, CSS. If you ever learn about web development, you might have heard, these 3 are the building blocks for any websites. HTML is used to mark up the text or content of the website, where the title go, where do you want to have a paragraph, and so on and so forth, and a whole sort of structure. And CSS is used to style a website, because everything that we've done, it's essentially a website. And so this is where you can actually see the files that make up the website. So CSS is used to style the website, how big you want, what's the font you want to use, what color you want to use for each part of your website, and the size, the margins, and so on and so forth. And JavaScript is what adds interaction, which is the code that we've been working with. So in order to add an image, you want to add a file in this sort of inside of this project. You can create a folder here, create a file, or upload file. So I'm going to upload file. I already prepared a file. You can use any file. I recommend using a square image, because so we don't need to worry about the aspect ratio, even though we're going to learn how to work with a different kind of aspect ratio later. But for now, just for the sake of simplicity, try to find a square image, and I'm going to upload this image. Basically, I'm going to drag the image, drop it to the and drop it to this window, and now it should be uploaded. So and then you need to know what the name of your image is. So before upload, or even after upload, you can rename it. So give it a simple name, because now that we're writing code to access image, we have to use that image name. So if you have like a very long name, just more words to type. So give it a simple name. For me, I'm calling it abstract fluid, which is a sketch that I created a while ago. Yeah. So how do now we need to go back to sketch.js, and we can sort of close this part if you want. So how do we draw an image on the canvas? The first step is to create a variable that's going to hold the image. Again, I'm going to stop it for now so we can focus on the code. So I'm going to call it graphics. You can give it any name, graphics. And we are going to use a new function. Instead of setup or draw, we have a function called preload. Preload is a function that's run before setup. So setup is to get everything prepared, but preload is sort of even before setting up, you want to load all the images or any kind of files. Because we're working with website, you see how sometimes when you open a website with a lot of assets, it would show loading for a while. That's because those assets, images or videos, sometimes it can take a little bit of time to download or load to the page. And we don't want the website to start work until everything is loaded, because if things are not loaded and start clicking around, the website might break or doesn't behave the way you want. That's why and in the case of our sketch, before we do anything about the graphics or before we run the sketch, we want to make sure all the images or all the assets are loaded properly. That's why there's a separate function called preload that makes sure everything is loaded before the setup runs. And I'm also going to give this a name, 28, workshop number 5. Yeah. So in order to load an image, you start with the name of the variable, graphics, and then load image. Inside of load image, the load image is a function that load images for us. Very self-explanatory. But inside, we need to enter a text, which is why I'm using the double quote. So whenever you use any sort of text, because anything that's not inside of double quotes, it's the code. It's code that actually does something, be it a variable or a number or anything. But text is just text that's not, it's sort of just plain text. So in this case, it's abstract fluid, which is the name, and then .png, which is a name of my image. And you might have JPEG. So just make sure it's the right file extension. And now everything is loaded. Things are loaded in graphics. And then when you want to display the image on canvas, we use the function called image. Image start with the graphics that's loaded, which I'm calling graphics. So graphics, and then the position, so 0, 0, and then the width and height. So this is very similar to drawing a rectangle. The position, which is the top left position, by the way, and then the width and height. I like the image to be full screen. So maybe before this, let's take a look and see what it looks like right now. Let's run this. Yeah. You don't know my image, but I know that this is actually only a portion of the image because my image is bigger than the canvas. So that's why it's important to specify the width and height that you want to display the image in. So I'll use width and height, which stands for the width and height of the canvas. So now it's sort of zoomed out, or it's scaled down, so it perfectly fits my image. Yeah. So that's how to draw image. Any questions so far? Oh, good. And the next step, let's see how we can write some code to select a color. Because the idea of working with pixels is essentially, the idea of like, those virtual mirrors, essentially you are reading the color of each pixel and then do something about it. So now let's see, how can we read the pixel of a certain pixel of a certain image. And first of all, I'm going to, inside of setup, I'm going to change something called pixel density. And that's because this really depends on your computer, but most monitor or like the newer laptop or computers, or essentially the computer screen, has a high pixel density. What that means is in older monitors or screens, maybe there are like, let's say 100 or X number of pixels per inch. But now that number doubled. And because of that, in order to display everything in a, in a similar size, the way the computer treat a website or anything is to use two of the real pixels as 1 pixels on the website. But either way, what pixel density does, so pixel density, if you have a screen that has higher pixel density, it can cause certain problems for us for later. Again, I'll show you how you can work with a higher pixel density, but for now, we can manually change pixel density to 1, which means 1 pixel means 1 pixel. So that it's a lot easier. The calculation is a lot easier that way. So now that we've changed pixel density to 1, what we can do is to run this function called load pixels. So what load pixel does is you have image, load pixel basically load all the pixels on the canvas. It's important. It's not loading the pixels of the image, it's really loading the pixels of everything on the canvas. But because our image is covering the entire canvas, so the pixels loaded are essentially referring to, the pixels on the image. But there's a key difference though. Yeah, so if your image is smaller, it's going to load both the image and the background of the canvas. So then load pixels. Once pixels are loaded, we can then read let's see. We want to read a certain number of pixels. So let's see. What we're going to do is to use a mouse. Based on the position of the mouse, we're going to pick the color of that pixel and use that pixel to draw a circle or something. And how do we pick that color? Then we need to understand how pixels work inside of P5.js. So when you load pixel, everything is loaded into this variable called pixels. And one thing we can visualize it is we can print out pixels so that we can see what's inside of this pixel variable. We will be able to see it in console. But because pixel is inside of that's inside of a draw, so it's going to print a lot of times. So what I'm going to do is to run it and then quickly run this and then quickly stop. Yeah, because otherwise, if it keep printing and printing more pixels, it's going to freeze the browser, because that's a lot of pixels to display. So I'm just going to quickly run it and then close it. I think I might have frozen my browser already, or yeah, it looks like this part is not working. So yeah, I think that turns out to be a bad idea that I was printing the pixel. I'm going to refresh the page. Yeah, and hopefully it didn't freeze your browser? If it did, just refresh and hopefully that works. In the worst case scenario, you might need to close the file, close your browser entirely and open it again. I'm going to, so one thing we can do to avoid this is to move everything inside of setup. I'm going to move that in setup. And that's because draw runs multiple times, which is what crashes the browser. But if I put everything in setup, it's only going to run once. So now I can stop and now we can see this, what's inside of pixels. I see. So I think what froze the browser actually might be because I click on this triangle and there was too many pixels inside. Okay, I guess we are not either. Yeah, I'm going to refresh this again. Yeah, that's the case where I think I need to close the previous one and open a new tab. I think it's still apparently it's still too many pixels to be shown. Again, I'm going to move this back to setup. I mean, we can still do a workaround. I'm going to change this to 10 pixels, change the canvas to 10 pixels just for now. And I hope it's not going to crash this time. Yeah, it did not crash this time. The reason why I did this is because I want to show you how many pixels are inside or how many numbers are stored inside. So I changed canvas to 10. You can see that it's a tiny preview, a tiny image, but you can see how many numbers are inside of this pixel variables. And the answer is 399, but it starts from 0. That means there are 400 numbers. So if you do simple calculation here, 10 pixel by 10 pixel, how many pixels in total do we have? It's 100 pixels. So why are there 400 numbers? That is because for each pixel, there are 3 values that are stored. So the R, red, and G, green, and B, blue, and then the A for alpha. So all 3 RGB, A, all 4 values are stored inside of this array. The pixels essentially works like array, and everything is stored in there. So that's so essentially each pixel are represented with 4 numbers, and they are just going in a sequel. So 0, 1, 2. So 0, 1, 2, 3 referring to the first pixel, and then 4, 5, 6, 7 refers to the second pixel. Yeah. So that, or before we work with pixels, it's really important to understand that concept. So now, finally, we can let's remove print pixels. So load pixel, that load everything inside of pixel variable. So now, how do we get essentially what we want to get whenever we like to access a particular pixel? We need to calculate what's the index. So the first number, 0 to 399, that's the index. Which index of the color do we want? So let's start with getting the X and Y that we want. So X is the mouse X, and Y would be the mouse Y. So that is the coordinate where we would like to access the pixel. And then how do we get the index? Let index equal to Y times width plus X and then times 4. So what did I do here? So width, that's 10 pixels. So that's like in every row of pixel has 10 pixels. because each row, the first row has 10 pixels, second row. So this is how many pixels. And then Y is the height. Maybe this is when I should use annotate again. So these are the pixels. I'm only going to draw the top one, top couple of them. Okay. So it's going like 0. I think for each pixel is, well, so basically, let's start from 0, 1, 2, 3, 4, 5, 6, 7, 8, goes one by one. Then how do we calculate the sort of index of, let's say this one, right? So first, and remember, all this X and Y start from 0. So in order to get the index for this one, what you need to do is to first get the width, which is the width, and then times the y-axis, which is in this case is 1. Yeah. Again, this is a zeros. This is a zeros row, and this is the first row. So when you times 1, that includes all the pixels here, and then plus, depending on which pixels you are in terms of the X, like from left to right, 0, 1, 2. Yeah. So you plus X. So these are the total number of pixels, because the pixel that we are saying earlier at the bottom, the 400, it really just goes from left to right, left to right, left to right. That's how it works. This is how it's, this is the order of all the pixels. So width times X plus width times Y plus X, that's, you know, the nth pixel. But because each pixel is represented by 4 numbers, that's why we need to multiply this by 4. Change to a different color. So everything, this is the number of pixels, but then to do this times 4. And that gets us to, because this is 0, this one is 1, this is 2, I mean, in terms of X. So when you do this number of pixel times 4, what you're getting is actually the beginning of the pixel. So for instance, the 0, when you times 0, that basically didn't add anything on this row. So you're just getting the beginning of this pixel. So this number give you the first value of the pixel, like the RGB. This number give you the R, and then if you plus 1, that's where you get the index for the G RGB. And let me I'll clear this. I hope that was clear this. Is it clear? Are people confused? Any questions? So this is a total number of pixels that, you know, up until the X and Y, and times 4 is the total number of the actual numbers, because each pixels are consists of 4 numbers. And now when you want to, if you like to get the R color, the red color, that's inside of pixels. We're going to use index. So that's the R color. G, that's pixels index times 1. So index, the square brackets and then the number, that's trying to access, you know, a certain sort of a value. So the index is the first number, and then you get the right number, which is a number from 0 to 255 that represent a color. And B equals to pixels index plus 2. And finally, A equals to pixels index plus 3. So that's how you get all 4 values R, G, and B. Sorry, R, G, B, and A. And now you can use the 4 numbers that you retrieved from this from the pixels variable or array, and use that as a color. So color equals to R, G, B, A. Yeah, RGBA. Yeah, and just something on my screen. Yeah. So color RGBA. And finally, what we want to do is to use that color. We fill that color and draw a circle at that position, with a diameter of 50, and draw a circle at X and Y. And let's see if it works. Right now, it's really tiny. So let's change the pixels back to 100, back to something number. Sorry, 400, 400, 400, 400, 400. So now, I just realized that because I put all code inside of inside setup, it's not going to be interactive because, yeah, it's once it's loaded, everything stays the same. So starting from background, you want to put it inside of the draw, and now it's going to be interactive. You see how as we move around, we're essentially picking the color of that we're getting that color and using that color to draw a circle. That's what's happening here. Any questions? I know this math part is the calculation is a little tricky to understand, but once you do, the more you do it, and the more I think easier to understand. And later, once everything is lined up in a pixel, hopefully that's like easier to understand. Yeah. And one thing you might notice, like in the case that what I did here, there was error. It says color was expected number for the first parameter. So essentially it's saying that it does not exist. That is because when I move the mouse around, sometimes I can move mouse all the way to outside of the screen. So what's going to happen is inside of this pixel index, we're going to get a number that's like larger than the total number of pixels because we're outside screen. So it's trying to access a pixel that does not exist. And that's where it creates this problem. This is why instead of mouse X and mouse Y, we need to add some constraint to this value. We want to make sure the value is always smaller than the total width and total height. And to do that, we have this handy function called constraint. So somewhat similar to map. I mean, first you enter the value that you want to constrain, which is mouse X. And then what's the lowest value you want it to be? 0. What's the highest value you want it to be? Width divided by width minus 1. And that again is because the number of pixel, even though the width is 400, but in terms of the index, it starts from 0 at the first one and 399 for the last one. And so that's why we don't want the mouse position to be anywhere larger than 399. So so what constraint does is make sure, even if mouse axis is 1,000 or 2,000, it will convert this number to a number that's in this range, 0 to 399. So make sure that the output number is always somewhere between 0 to 399. So that way it ensures that X does not exceed the total width. And same thing for the Y. sorry, constraint, there was a typo, constraint y, smallest is 0 and largest is height -1. This way we don't have that error. Like you see how the circle, even when I move the mouse, the circle just stayed on the edge because that's the smallest, that's the largest and smallest value it can be. So far, so good. Thank you. So that's how you use pick color with mouse. So that's how you do that. So, and with this alone, like, you know, if you want to be creative, you can, let's say, we can do a couple of things. A duplicate. So as long as you have this color picker thing, then based on the color, there's a lot of things that we can do. So for instance, we can change the size of the circle. So maybe instead of 50, based on the color, we can, you know, make the circle size different. For instance, one handy function is called brightness. So brightness, and inside you can put the color. What this does is to extract the brightness or calculate the brightness of this color that's given. We have the color C and we get a brightness. And brightness, I believe, is a number anywhere from 0 to 100. Yeah. And then you can map it to a different number. So you see how when it's dark, it's very small. When these colors are pretty bright, I think they are pretty much, yeah, same size. But when it's darker, it's smaller. Yeah. So this is how you can add a little bit of interaction to the color picker. So depending on the brightness of the color you draw, yeah, the size of you see how when it's like almost black, it's very, very small. Depending on the brightness, the size of your circle is different. The diameter of the circle, yeah. Pick color with mouse and with interactive dimensions, or maybe interactive. Yeah, I think I'll leave it as dimensions. And now let's create another one. Duplicate again, and this will get interesting pretty quickly. So now instead of picking one color, what if we want to have a grid of color, which is what's going to form those large pixels? So these pixels are the actual pixels, 400 times 400, and each pixel is 4 numbers, then times 4. These are all actual pixels. What if we want to display the image in like a pixelated format, so that in a pixelated format, that there are a lot, you know, less but larger pixels. In that case, we like to have a for loop. You know, we're revisiting this idea of a for loop and also the grid. And so let's do that. So after loading pixels, instead of picking the color of any accent of the mouse X and mouse Y, the color we like to use is going to be the what is it called, the actual, you know, in a position in a grid. So we're going to create a for loop and let row equals to 0, row smaller than row. So and row plus plus. So similar to what we did before, but we need to define the number of rows somewhere. And let's do that at the beginning of in a global variable. Declare a global variable. So number of rows, maybe start with 10, number of columns, maybe also start with 10. These are the global variables. And inside of a setup, and also declare tile width and tile height. And inside of a setup, we're going to calculate tile width and tile height. So width divided by the number of the number of columns, and tile height is height divided by the number of rows. The reason why we did the sorry, there's no let here because we already initialized it in the global space. And we initialize it in global because we would like to access it in both draw and setup. And the reason why we have to put tile width and tile height calculation inside here is in the global, again, anything that's P5, we cannot use it in the global because P5 related syntax or keyword can only be used inside of setup and draw. And the width and height is a special keyword for P5.js that give you the width and height of canvas. So you have to use it inside. And also because in the global, in this global scope, the canvas was not even created yet. So only inside the setup, after create canvas, the canvas created. And only after creating a canvas, you know the size of the canvas, the width and height. Because if you put this before create canvas, this will not work because width and height did not exist before canvas was created. So again, these are all very similar thing we did. We just put them at like a slightly different location. These here, and then we did the calculation over here. And then later we're going to use the number of rows, number of columns, and tile width and tile height. Yeah. So the reason why this time instead of R, I'm using row, and is because we have R here already, which represent the red in this case. And that's actually one reason why sometimes you really don't want to have letters because they might conflict. If we have the same letter, same name for a variable, it's going to complain to us. So we want to have a different name. So in this case, I'm going to call row as row instead of R. And then instead of a row, let's focus on the code for a second. For each row, we're going to write a loop for each columns. So column smaller than columns, column plus plus. So this again is a grid that we've used to create. So maybe let's not worry so much about the pixels yet. Let's just create a grid. And so that's a for loops. And finally, let's calculate the x of each tile. So let x equal to let's see, tile width divided by column, and let y equal to tile height, not divided, sorry, multiplied by column, and then tile height times the current number of row. So that's how you get x and y. Again, this is also something that we've done before. And more specifically, if you want to get to the center of each tile, we can do the half. We can add half of at a 0.5, so that we are getting the center sort of coordinate of each tile. And because of that, so this time the x and y in this case, it really needs to be it has to be an integer, and since we are bringing some like yeah, we are bringing fractions here. So just to avoid, I mean, right now we are it's all divided, so it's 400. So I mean, we're not going to get any sort of decimal. We're not going to get any fractions or anything. But just to make sure that it is a integer, what we can do is to write another sort of math function, floor, meaning to round it up to the smaller value. So if the number is 5.5, it becomes 5. If it's 5.1, it becomes 5. It's even if it's 5.9, it becomes 5. We want to round it down because usually it's safer to round it down, because when we're working with number of pixels, if it rounds up by accident, and if there's no such pixels, then that's where that's where things break. So we always want to round it down, so that it's always within that range. Yeah. So rounding it down is like a safer approach in general, unless you know that exactly what you want, and that rounding down does not work. Rounding it down doesn't work the way you want. Then you can consider doing either round or scale for ceiling, sort of getting the rounding it up. But yeah, rounding it down is usually getting a smaller number is safer. So now I'll make sure the x and y are integers. And let's finally draw the rectangle. So before I draw the rectangle, I want to change rectangle mode to rec mode center. And then I draw the rectangle. So x, y, tile width, tile height. Yeah. You see how we get so essentially we get a grid now. Yeah. The color still changes. That's because of the rest of the code that we have. It was loaded. It's all the image was color was loaded, and then we are still changing the color. Yeah. And you might notice that fill comes after those rectangles, but the color still changed. That's one particular concept that I did not explain before, and that, even though we've mentioned that fill has to come before drawing a certain shape, but because draw runs again and again, it loops x number of frames per second, and because of that, what's happening here is it's changed the fill color. You switch the paintbrush to a certain color, and then you draw that circle. But after drawing that circle, you go back to the beginning, and you are still holding that paintbrush, that color paintbrush, until you change it. But because we didn't specify any color over here, the rectangles, you are using that same color for those rectangles. That's how you see all the rectangles are the same color of that circle. And so if you want to avoid, that, then you can specify your fill color over here. Let's say white, for instance. So now the rectangles are white, and the circles are in a different color. The circle is in a color that's picked from the image. So now we've had the fill. So now we have the grid. The only thing that's left is to use the color of each pixel of that corresponding pixel to fill this rectangle. How do you do that? We pretty much have all the code here already. So now instead of the mouse position X and Y, we are going to use this X and Y that we calculated for each tile. Yeah. So because we use the same name here, we can simply copy. We can copy all this inside the for loop. inside this full, and we don't need this anymore. This is for the mouse moves. So we don't need this anymore. So now essentially what happened here is first we calculate the X, remember this X and Y refers to the coordinate on the canvas. So based on the column number and row number and tile width and tile height, we calculate the coordinate, X, Y coordinate on canvas. And then with that canvas, with that X and Y, we can then draw a rectangle. I think the color, fill is over here. So we would definitely want to move fill at the beginning. Well, not like that, actually. I think the rectangle, we should move the rectangle later to about here. To like after fill. So now circle or rectangle, that's up to you. So circle size is still based on brightness. So let's comment this out for now. You'll see now, you see all the pixels. And what happened here? Again, let's revisit this. You're doing everything for each row, for each column, and then we get the X and Y coordinate on the canvas. Whenever you know the X, Y coordinate on the canvas, then you can calculate the index. And this index referring to the index in the pixel array, which contains all the pixels, and each pixel is 4 numbers. So that's the index we get. With that index, we can get the first value of that color, the R. And then similarly, we get +1, then we get the G, and then the next one, we get the blue, and then next one, we get alpha. So with RGBA, we can then create a new color based on the value that we retrieved. We use that color to fill, to set the fill color. And we change direct mode to center because when we calculate the X, we are using the center of the of each tile. And we are using that center because later when we are doing rotation, it's a lot easier to work with. So X, Y, and then the tile width and tile height, that's calculated based on each tile. And there you have it, pixels. And now, obviously now it's a little bit hard to see. You can change the pixels to a smaller number. That's where you can see those pixels, maybe or 50, where you start to see that this is how you can sort of converting this regular or high resolution image to a lower resolution image. You see the pixels because we create a grid and we use grid, and for each tile we are picking a color from the image and using that color to fill the entire pixel. Does that make sense? Any questions so far? I know this is the last session. This is a little more advanced, a lot more math, a lot more calculation going on here. But hopefully the least you can do is to follow along and get it to work. But I'm going to continue, but feel free to ask any questions in the chat. So duplicate. Are we indeed visualize the borders of the pixels of the image? Are we indeed visualizing the borders of the pixels of the image? Can you rephrase your question? I'm not sure if I understood what you meant. Essentially, if I understand your question correctly, I think the color that we are picking is the center. It's not the border. It's the center of each tile or each area. You can, based on my understanding now, use annotate. So So we have a image, and this image has thousands and thousands of pixels. We want to create a lower resolution image. What do? We first create a grid, which is the resolution we want it to be. For instance, in this case, we want it to be 4 pixel by 4 pixel. And then for each pixel or each rectangle, we need to use a color from the image. Which color do we use? Currently, because of the calculation we are using exactly the center pixel as the color that we're using. So for each tile, we're using the center pixel for the color of that entire tile. Does that answer your question, or did you mean something different? So right over here, we're with the row number and column number, we're calculating the center coordinate. The XY is a coordinate, which essentially is the number of pixels. Every image has pixels, and we make a grid to match it with the pixels of the image. Exactly. So yeah, every image has, basically image has more pixels. We're just using a smaller number of pixels. And when with smaller number of pixels, then you have to decide where does the color come from. And currently the method that I'm using is picking the color from the center of that tile. So these big pixels, I'm calling it tiles. Let's make it slightly bigger now. Maybe even just 5 by 5. Yeah. So why is this one like blue? That is because the center, the very center of this rectangle, the color of the original image is blue. And then the second one, why maybe the third one, why is this pink? That's because in this area, the very center of this rectangle, the corresponding pixel inside of the image is that color. So that's how we're visualizing it. And this is why if you increase the number 100 by 100, you see it because, yeah, like the tiles become smaller and each tile is colored based on the center pixel from the corresponding image. I hope that answered your question, but if it didn't, you can please elaborate on your question. Yeah, so that's what it does. And obviously you can also remove the stroke if you prefer that aesthetics. For instance, no stroke. That's up to you to see how, yeah, no stroke. And now it looks more like a pixelated, even more like a pixelated image, because usually there's no sort of stroke or border around pixels. Yeah, this looks more like a, if you have an image like a portrait, then in this case, even with this number of pixels, you can probably recognize the portrait. My image is a little more abstract, so the result is also a little more abstract. Any other questions before we move on? Okay. One simple change that we can do is instead of rectangle, these dimensions. So let's see. Pixelated image. And instead of rectangle, we can simply use a circle. Or in this case, because we have both the width and height, I'm going to use ellipse. It says an interesting fact because you can see the original image. Let's make it this a little, maybe this can help you understand the pixels as well. So we have a color, but underneath all the circles, we can still see the original image. Yeah. And for instance, if you do not want to see the original image, what we can do is the reason why we see the original images inside of the draw, what happened is first we draw the image, we draw the background, and then we draw the image. After drawing the image, we load the pixels. After loading the pixel, we draw the circles. So the circles are essentially on top of the image. If you like to cover the image, we can simply cover it with background. But it's really important where you put the background. You want to put background after load pixels. And that is because load pixels will be loading pixels, loading all the pixels before, up until that point. So if you put background here, essentially you are covering the image before you load pixels. That's why all the pixels that are loaded are light gray. So which sort of which defeat the purpose of what we are doing. So, but we can totally put background after load pixel, because at this point, all the pixels are already loaded. Even after I cover it with background, the pixels are still there. You can still use it the way you want. So now it has like a light gray background. You can switch to a black background, white background, whatever background you want. Yeah. But the first part is what help us load the image and then load all the pixels. So we do want to keep that part. Again, this can be a slightly larger number. So rectangle pixels, circle pixels, really the same idea. So now let's see how, now we've learned, know how we did the pixel density one. And maybe I'll make this bigger so it's a little easier to see. Let's see what will happen if we remove this line. If we remove this, you see how the image is a little bit stretched. So now that's because all the calculation is off, at least for my, so this is really depends on the exact screen that you're working with. If you have a fairly new laptop or computer, most likely you have a high density screen. Otherwise, maybe if your screen density is already 1, then that doesn't make any difference. However, keep in mind that your sketch, if this is your work, you like to share it with other people, so the final result depend on the pixel density of the person who are viewing it. So even if it works on your screen, it does not necessarily work on other people's screen. So that's why if you like to be sure, you can switch it to pixel 1. Otherwise, now we can learn how we can work with more pixel density. In order to know the pixel density, you can simply just print it. Oops. Print pixel density. Or pixel density, pixel density with the parentheses. You see how it shows, so print pixel density. So pixel density, when we provide a number 1, that's the pixel density. But when you call it without any number, it sort of returns the pixel density, meaning it gives you the pixel density so you can actually use it. So when I print this out, for me, it prints 2. That's because my pixel density is 2. Yeah. That means horizontally, whenever, this is what we are mentioning. I think in one of the sessions, I mentioned how even when you set the pixel to 400, when it comes to the actual display, it's actually using 800 times 800 pixels to use, because now our screens has so many pixels that it's, so it's a little, like the number is a little bit different from, so the number that we are using is not the same as the actual number. But if you set pixel density to 1, that's the exact same number. Yeah. But so that when you set the pixel density to 1, there is a downside. That means your image is actually more pixelated. So your image, right here, you see how when I zoom in, all the circles are fairly pixelated. I don't know if it gets across over zoom, but because I use pixel density 1, it's pretty pixelated. However, if I remove that and I zoom in, you see how those circles are much clearer. Yeah. So pixel density 1 is easier to work with, but ideally you do want to use a higher pixel density. So let's see how we can fix this. First, you want to define a variable, a global variable that you'll be using. I will call it PD, stands for pixel density. And inside of a setup, again, because this is a P5 specific function, it has to be called inside of setup or draw. So PD equals to pixel density. Yeah, I'm doing this instead of directly using 2. I'm doing this so that on my computer is 2, so it works for 2. And if someone else's computer is 1, then it will still work because we're dynamically adjusting our calculation based on, we're incorporating pixel density as part of the calculation. Yeah. So what pixel density did is, like I mentioned, 400 by 400 becomes 800 by 800. Basically, 1 pixel wide becomes 2 pixel wide, and 1 pixel high becomes 2 pixels, sort of the height. And so in the calculation, now, this, remember how, let's see, where was, yeah, X and Y. So column, tell width, right? So X still referring to the coordinate based on the 400, 400. But then how do we get but the index is actually now is going to be 4 times bigger than before. And that because it's doubled in width and doubled in height. So in total, it's going to be 2 by 2, 4 times. So now all we need to do is that, so now instead of Y times width, because width is 440, you want to actually get that 80, so times PD. So this is essentially, we are, multiplying with this 400 by the pixel density. And then plus 4, plus X, the X, again, X referring to the pixel density in terms of X referring to the, well, actually, I think I missed one thing. Yeah. I think one easy way to do this is, let's see what, because we don't want to mess up the X and Y, yeah. So pixel density, let's add parenthesis, or maybe let's, for the sake of, readability, let's break this down so that we're not just working with in that one large equation. So what's calculated with? So this is sort of a long variable, is kind of long, but just so it's easier to read, calculated width equals to width times pixel density. And what's the calculated height? Which I think, yeah, height is not used, so we don't need to worry about height. So pixel density width. So for instance, my pixel density is 2. That means my actual width is 800. And then what's the calculated Y? That'll be Y times pixel density. So if the Y coordinate is 10, it's actually 20 in the higher pixel density. And then what's the calculated X? That's X times pixel density. Yeah. Then finally, when we do the calculation in the index, we simply need to use the calculated width, calculated Y, and calculated X. And notice how I did the pixel density here, so we don't need this anymore. So essentially, we multiplied each of this number, the width, the x and y, all within the pixel density. And now we get the normal, the image that we want. And now we zoom in, we see the higher resolution. Any questions? Okay. So pixelated image with high pixel density. Yeah. So that's considering the pixel density. And now, now that we have the pixel density, so let's leave it with high pixel density. So then how do we work with webcam? We're going to save this. Make sure you save this. We're going to create a new one. First, I'm going to show you how we work with webcam, and then we're going to learn how to combine the two sketches. So how to use a webcam? For webcam, it's surprisingly easy. Again, thanks to P5JS. We start with a global variable, and this time let's call it capture, as in it's capturing image from of us. And then inside of a setup, we want to essentially wanted to link the webcam to this variable capture. So create capture. So now we're using create again, create capture. And what are we using for the create capture? We're using video, which refers to the webcam. And now, essentially, all we need to do is to use capture just the same way as the graphics that we've used earlier. So for instance, I can draw image and capture 0, 0. Let's see what happens. You see how there's you can see two images of me. That is because the top one, which is inside of a square, is our canvas. The bottom one, however, is a separate what's called HTML element. That essentially, that's just the part of the website that shows our image, which gives us a good preview, but most of the time we don't want that, so we can hide it. To hide it inside of a setup, we can write something like capture.hide. So that way it only shows in the inside canvas. But for now, let's keep it because it's going to be a good reference. Workshop number 5. Webcam example. Or maybe using a webcam. Yeah. So that's that. But now, if you're running this on your browser as well, you'll notice when I move left, when I move to my left, the image or the image of me will move to my right side. That is because the camera is facing me, so it's cameras. When I move to my left, the image will move to the camera's left, which is my right, and that's where it's not really intuitive, especially when you're working, when you're creating something like a mirror, or on your phone when you're taking a selfie. It just makes much more sense. When you move left, the image moves to the left. So we need to do a little bit of manipulation to counter that. And before we do that manipulation, what we want to do is one other issue that we have here is that the image is sort of cut off. It's also not centered. So how can we do it? So far we've only specified the position, capture 0, 0. We can also specify the size. width and height. But now the good thing is it's showing my entire image in the canvas, but I'm sort of squished, I'm squeezed sort of to the middle. Usually you don't want that, again, unless that's an effect that you're looking for, that's totally fine, which is why you have the flexibility to do that. If you want this effect, you can totally do that. But assuming you want a regular proportion of the image, then the image actually provides us with a pretty handy way to control that. So we can look up P5JS image reference. Instead of reference, I'll search for image. This image function, there's this image and there's this image function. And in the image function, then it goes in depth to explain how you can put one aspect ratio to a different aspect ratio, or how you can even use like a portion of image to only select a portion of the image. But what's important here, that what I wanted to show is that if you look at the syntax, there's image. First, you specify the image, the position, and width and height. So in this, that's what we did. But then we also have this second option, which is to specify the dx and dy. What is dx and dy? Dx and dy is the destination rectangle. So now we are specifying the dx and dy, which is the destination, which is where we want to put. So dx, dy 0, 0, top left. And then d width and d height. Basically, in the end, how big do we want it to be? We want it to be the same as the canvas. So d width and d height is exactly width and height. And then finally, we can specify the source x and source y. So where do you want it to, where do you want, like how, so that's where the slicing comes in. If you want to slice a portion of the image, you can specify, maybe you don't want to start from 0, 0. But in our case, we want to use the entire image. Source x, source y, so 0, 0. So that's referring to the 0, 0 of my source image. And then, so source width and source height. So that is going to be capture.width and capture.height. So that referring to the entire image, width and height. So for now, nothing changed. Nothing changed. And what we want to do is, what we need is the last part. That's where it's really helpful. Fit. There are different ways to fit. Let's see if there, yeah. It's the fit can either be contain or cover. And let's see what it does separately. So it's all uppercase, contain. So when it's contained, it makes sure that it shows the entire image. So even though it has to resize it a little bit, make it smaller, it shows the entire image. But for the purpose of this workshop, I think I prefer the cover. So even though it's cropped, now it's a center. So it's covered. Like it used a source image to cover the entire canvas, or the whatever size that we specified. In our case, it's the entire canvas. So using a webcam to cover entire canvas. Does duplicate. Now the one last thing we need to do is before we combine with the other sketch is direct, is sort of the direction of the image. Right now it's the opposite of what my brain thinks. In order to do that, we can flip the image, like flip the left and right. How do we flip it? We use what is it called? The scale. Scale is a function. Scale is a function that change the size of image. So right now it's just scaled it down, scaled it up. So for instance, 0.5, 0.5. Now it's scaled down. I'm scaling down so it's a little bit easier for to see what's going to happen later. What we can do is to, for instance, make one of the value negative. I think it's still somewhat difficult to see because what negative does is while scaling, it's also flip to the other side, sort of flip the image entirely. But the reason why we cannot see it is because it flips to the top. So now we cannot see it. It's outside the canvas. But how do we decide where do we want to flip? That's based on, it's always flipping around the origin. And do you remember how we can move the origin? We can move it by translate. Yeah, with the function translate. Let's say if we move, translate 200 and 200, you see how after translate 200, 200 and move my origin, which is top left corner, to the center now. Now, it's a lot easier to see what the flip does. If I flip the y-axis, it flips upside down. If I flip the x-axis, then it flips to this side. But of course, I don't want myself to be upside down, so I don't need to flip the y-axis. So now, when I move to the left, the image to move to the left, to my left. So that's what I wanted to see. And instead of 0.5, I like to use 1 instead. And now, again, instead of translating into 200 and 200, where do I want it to be translated to? I need to translate to width and 0. The reason is width. Basically, I'm translating origin all the way from the top left to right left, 0, because the y-axis is 0, so all the way to the right left. And then I can flip from the right side, which is outside the canvas, and flip it back to the canvas. Let me try to use annotate to demonstrate this. So this is your image. This is the origin. If you shift the origin over here, so let's say, yeah, if you shift the origin over there, it moves from here to there. And so let's say I have a letter B. When I move, what translate does is to, so remember, this is our canvas. The red square is our canvas. So when you move the, let's see, rectangle, back to white. So what translate does is to translate the origin. So the origin got moved. That way, the letter B move to the right. But what scale does with the -1 for the -1 for the x-axis is to flip the entire image. So this side got flipped all the way here. And that way, we are showing this image exactly flipped as before, which is what we're trying to achieve. Any question regarding this? Okay. Clear screen. And that's how we get the image of the captured image to fit the canvas. And now we don't really need the preview anymore. We can just hide it. So now we can have a clear view of just the webcam. Yeah, without that preview. So webcam, using a webcam flipped image. So finally, now what we need to do is to combine the two sketches. We can move what I'm going to do is I'm going to start a new editor, and I'll bring back use where is it? Bring back pixelated image, yeah, with high pixelated image with high pixel density right here. And I'm going to duplicate this. Webcam. Yeah. So how do we integrate the webcam here? What do we need to do? One thing we need to do is to create a capture. Let's capture, but let's see. Yeah, let's create a capture. And instead of a setup, capture equals to create capture and video. So just the same thing that we are reviewing, which, you know, the image is at the bottom. I don't like that, so capture.hide. That way we don't see that. And then how do we use the capture? Essentially, instead of graphics, we can use, we can change this to capture. Oops, I think I don't know what I can. We can change this to capture. But remember how we did a lot of, actually changed a lot of things. So instead of, I mean, we can give it a try if we just simply use capture. I mean, it's already working, but it's not doing all the thing that we are trying to do earlier here. So we can copy all this thing. So instead of the regular image, we are copying all this, and background, translate, scale. I mean, the background is not needed. We are translating, and then we're scaling. We draw this image based on, you know, this cover thing, and then we load pixels, and finally we draw a background to cover it. One thing that I noticed is right now the image is still flipped. The image is not the right direction that I want it to be. And why is that? That's because we did scale. I mean, because we did the translate and translate and flip, it applied to both the image that we're drawing and also the rest of the code. So now it's like a sort of a double flipping. So what happened is you flip the image, but then later when you supposedly you should be drawing the correct width and height, correct tiles, but because the image is flipped, now you're still viewing a mirrored image. But one other thing that we've learned before is push and pop. What push and pop does is to save the current setting and then reload the current setting. So anything that's inside, because we don't want we want the translate to only take effect for this image. So push and then pop after loading pixels. So push and pop. What this does is the translate and scale will only affect the image. It's not going to affect anything else. And now it's loading to the proper, if you have multiple cameras, how do you pick the camera that you would like to use? Yes, very good question. In that case, I believe in P5JS, it actually does not provide any way to pick the webcam. So there's a couple of options. If you have, in the browser setting, sometimes you can choose which camera you like to use with a website, or maybe even for a particular website, which camera you like to use. Let's see if there's a great capture. Let's give it a see if oh, actually, if I refresh, you see how right here, at least in Firefox, it's asking me to choose a camera that I would like to use, and then I can remember this in yeah. So that's one option. The browser, with the browser, you can choose which camera you want to use. But if you really want to write code to pick the camera, let's see if there's an example. I mean, I've done it before, but I don't think P5.js natively supports it. Right. So I don't, again, I don't think it's explained here, but essentially this is how you can create a simple webcam capture versus there's also a way where you can add some constraints or basically some specifications. For instance, like what's the width and height of the capture? What's the number of frames that you like to choose, whether you want to include audio or not? Yeah, and then you can use these constraints to create a capture. You see how this create capture is a little more complicated. So that's something you can do. But one of the options, which is not shown here inside of a constraint, is to choose a specific camera. So in one of the options, you can also choose like which camera would you like to use. Yeah, so that's one way to go. So, but this is no longer sort of somewhat like simplified code with P5.js. This is slightly more complicated. Yeah, where you can specify the exact camera. So, for instance, camera P5.js. That's also one question that you can ask. What is it? You can ask ChatGPT maybe, which or choose camera. P5.js, choose camera. Select camera. You see how other people has written examples. And by the way, I was going to show Dan Schiffman in the end. Dan Schiffman is a faculty at ITP, and he's been creating P5.js tutorials and just creative coding tutorials for years. When I first started learning coding, I watched his videos, and even today I watch a lot of his videos. So I highly recommend Dan Schiffman's video. So after the workshop, if you like to continue learning creative coding, feel free to check out his video. His YouTube channel is called The Coding Train. But basically, if you do a little search, you should be able to find ways to do it. Yeah, way to do it. But I'm not going to cover it in this workshop because we're already running out of time. So Nature of Code. Yes, thank you. Yeah. So Nature of Code is a book written by Dan Schiffman, who in which he was writing code to emulate nature, like the physics that we mentioned, how to emulate physics. But even in his book, he explicitly said, like, life is short. We've learned all this, and then now we can use other libraries to emulate physics instead of like something like Box2D to emulate physics instead of doing all the calculations ourselves because someone else already did it. It's like now you are using a computer. You can use the computer. You can just enjoy the computer other people make instead of starting from scratch, making your own chip, making your own computer, and now work on it. Yeah, it's there's no need to do that. You can just use other people's sort of product or whatever other people has already made, as long as it's legal, obviously. And where were we? So pixelated image with so that's the webcam. Now it's working. Now let's duplicate. But the idea, I mean, I think the basic idea is there already. We can now adjust the number of rows or pixels, rows or columns. So if you want to have a more pixelated image or less pixelated image, personally, I find it more interesting when the image is more pixelated, meaning has less pixels. So it's more abstract. And we can, instead of ellipse, we can then use rectangles, and rectangle, we can also add a little bit of rounded corner, which I'm going to do a tile width times maybe 0.2, but I forgot to change the rectangle mode, so I like to change rectangle mode to center. Yep, so that's where it's rectangles, and then we can change the sizes. For instance, yeah, let's add rotation. Rectangle. First, let's try to add rotation to this. In order to do rotation, remember how instead of X and Y, we would first push. Yeah, again, this is something we want to manipulate. That doesn't affect the rest of code, so push and pop. And instead of push, you first translate to that, you move the origin to X and Y, so you can later then rotate, and then the rectangle 0, 0. So far, nothing changed, but now we are able to rotate around this, around the origin. Let's just give it a try. So 2, everything rotated. But now we don't want it to be a fixed number 2. We want it to rotate based on something. For instance, similar to what we did, we can rotate based on the brightness, for instance. So maybe we can, again, just for the sake of readability, we can break it down to multiple lines of code. So let rotation equal to brightness. So if I'm going to use brightness of the color, which is a C, use the brightness of the color, and then I can map this brightness to another number. The brightness is a number from 0 to 100. Again, that's the default value for brightness that you can find inside of a reference. So 0 to 100. And for rotation, maybe I want a number from 0 to 2 pi, like you mentioned, how if I want a complete rotation. So rotation, we've got there. Now we can put rotation inside of a rotate function. So now as we move around, you see how the rectangles actually rotate based on the brightness of each tile. And besides rotation, let's again duplicate. Besides rotation, we can adjust, for instance, things like the size of the image, a lot of different things, size of the tile, a lot of different things. And one example, if you want to achieve something that I did in the example, yeah, just to make it look a little more dynamic, what I did was to add a scale for both the width and height. Yeah. And I don't know why I keep crashing every time I start putting the push and pop. Maybe, yeah, maybe you can share the link to your code again. Most likely, yeah, something. I think maybe the push and pop didn't line up properly or something. Yeah, feel free to share a link and I'll take a look. Oh, I'm sorry. Yeah, I'm sorry it didn't save. So all I can say is next time try to save it more frequently. Were you were you able to? I hope you at least have some. Maybe that particular version was pushed and popped and saved, but I hope you actually have some previous version that you can get back to.
Yeah, I have the one with the circles. It's just started crashing when I wanted to change it to the rectangle mode.
Right. So rectangle, I see the one with circle. So when you switch to rectangle, do you want to try it again and maybe save before we run it? So if you run into the same, it's kind of hard to debug if I don't see the code. So maybe just give it a try again. If it happens again, save it before you try running it. And if it
Yeah,
happens again, and if it
yeah,
happens
I'll
again,
now.
and I can. Mhm. And I mean, in the meantime, I'm going to add scale to both the width and the height. And let's add it around, where should I add it? Maybe after color. So I can add a scale width or width scale. I don't know which makes more sense. Scale width. Which, so for the scale, I'm going to use this has nothing to do with the pixels. This is just to make the whole image a little more interesting. What we can do is to again utilize the x and y pixel number to sort of create a different, to change the width. So for size, sign x, and then we want to map this value from -1 to +1 to maybe the scale. We maybe want it, the minimum we want it to be like maybe half of the width, and the maximum is 100% of the width, something like this. Maybe I'll start with lowercase and multiply width with scale width. That changes this. You see how now it sort of goes almost like a sign. If I move away, you see how it's sometimes thinner, sometimes wider. And then we can do something similar for the height. Oops. Something similar for maybe, so that's just for the x. And then we can also add y, maybe plus y. You see how now it's sort of, again, this has nothing to do with the pixels itself. This is really just manipulating the sizes to give it interesting effect, like we've done with other grid, just to make it more interesting. So x and y. Then if you wanted to move, frame count divided by 10. So you see how this there's like a wave moving sideways. Yeah. And then if I think that's a little bit too much, I can make it a little more. Basically, I divided both x and y by 2 so that the changes becomes more slower, or less. And similarly, we can do this for the height as well. Scale height, to change the height as well. And again, this we can maybe, give it a different value, like so that it moves at a different sort of interval. Yeah. So you see how just by moving circles around, that's already like more interesting than before, than just tiles. And One other thing that we can do is for the rotation, let's see. I think, yeah, I feel like the height didn't change. Yes, that's why. I didn't apply height. Yeah, so for height, I have just applied height to, yeah, scale height to height as well. So now, yeah, sometimes become really small, sometimes become really big. So this is something that resembles the example that I shown earlier. Any questions? So now we have, let me move this right here. So now we have a sketch that reflects our image. You can wave around, in front of your webcam. It shows your image. Any questions before we wrap up? Thank you, Water. Thank you. Thank you. So is it possible to mix it with image? What do you mean by mixed it with the image? Like you like to see the original image, or what do you mean? Like, for instance, if I comment out background, you can see the original image. So the original image is underneath, and that pixel effect. So this is actually also sort of a happy accident. So that's like interesting effect that I didn't see happening.
Hi, can you hear me?
Yes.
I mean that in the previous code we introduce an image for this effect, that abstract image that is on your background. Now, I mean that is it possible that we have that image as well, mixing with our video?
So do you want to have that previous image at the bottom, or what do you mean by
in the background?
mix? In the background?
I mean,
yeah,
yeah.
that you totally can. So right now you see how I draw the image, I load the pixels and everything, and then I use background. So what background does is background covers the entire thing. Now, if you want the image over there, then you can use image with the previous image that we have, which is called graphics. So graphics 00 width and height. Yeah, if you're referring to having that in the background. So now that image is in the background. If this is what you meant. So yeah, so yeah, like if you want image, you can simply use image to draw image, and then all the rest will be drawn on top of that. So again, as I say a lot, when you are the programmer, the coder, you really have full control over what's happening here. So whatever you want, you can just whatever you can do, whatever you want with code, basically. And for now, I'm going to comment this out. Any other questions? This is the last session. This will be the last opportunity to ask questions. And in future, if you encounter any problems, feel free to shoot me an email, and I'll try. If I have time, I'll try to help you with any issues. Otherwise, there's ChatGPT that you can consult with, and Google is always your friend. Where there's a lot of especially for something like P5JS, there's really a huge community of people that really support each other, and there are forums that you can ask questions at. Share the link here. Which link are you referring to? Like the forum, or I believe for processing, there's a processing forum. Yeah, Processing Foundation has a forum. that talk about, I think that focuses a little more on processing. I'm not sure if there's a P5JS particular one. And then in P5JS, there's also a Discord community. There's also I believe somewhere there was a Discord link invite contribute. Yeah. Can't find it right now. I'm in the Discord channel. Not in community. Teach, learn, libraries, reference. Maybe just in home. Not really. I believe you can find it. P5JS Discord. Discord server. I think, yeah, maybe it's this one. I'm not sure why. I'm pretty sure I've seen it before. I can't find it right now. Maybe I should search Discord in here. No, Discord. Oh, it's at the very bottom of the page, the Discord channel, and then you can go there as well. Yeah, there you can ask questions over there as well. Overall, P5JS is a very friendly and welcoming community, and there's a community statement about of P5JS that you can read. P5JS community statement. Yeah. So what's beyond this workshop? This is the last session. First, I really just want to say thank you to all of you who've been participating consistently in my workshops. I really appreciate your support and your participation, and I really hope everybody has enjoyed the workshop. But the workshop is, so when reading a question, should we write and submit a code as a final project? Yes, so as sort of a final project, yeah, I can talk about that first. So as a final project, again, for me, I'm pretty flexible with the type of sort of homework or project that you work on. Basically, with all the 5 sessions, try to incorporate as much as you can, or but you know, it can be anything that we've learned. Just use anything we've learned, build a project that that you are sort of passionate about, that you really want to build. Because ultimately, I'm not really trying to make you do any particular thing. I'm really hoping to provide this opportunity or this platform, and then you can use this platform and decide whatever that you want to do. So, and also I believe that's also the best way to learn, because if you are doing something that you really enjoy doing, then you can, you that way you really learn really, really fast, instead of me asking you to do any very particular thing. So feel free to use anything we've learned and build any project that you like. And again, as always, post it on Instagram or send it over by email, and I'd love to check them out. And even in future, maybe one day, it seems like most of you are architects, one day if you use this in your like bigger projects that you incorporated, let me know. I'll be really happy to check out all kind of projects. And so that's that. And then in terms of learning beyond the workshop, one, you can thank you for all the kind words. First, you can subscribe to my YouTube channel. Hopefully I will start to be posting more creative coding tutorials. And also, like I mentioned, there's the coding train by Dan Schiffman. He has a ton of videos. He posts video very consistently, and a lot very beginner friendly. He has a lot of followers on YouTube. He builds all kinds of projects. One good place to start is, let's see if there's a playlist. I believe there's a playlist called Code, or so really just from beginner to like more advanced, he really has a ton of videos that you can check out. And he's also such a great teacher that really explains different concepts a lot, like very, very clearly. So if there's anything that, any sort of programming concept that you're trying to learn, you can always check out his video. I know a lot of my fellow artists and the classmates also, use referenced his video a lot. So I'm also going to share a link here. I can't find that particular video. I think I'm going to send an email after the workshop, including links. Yeah, so that's his YouTube channel. And always, as always, the official reference is always a good place to start if there's any function that you don't know how to use. And if there's, so like explaining how each function works, there's detailed description and all that. You can even submit any suggestions, like if there's any errors or anything, you can always submit suggestions. And also, if you get a little more advanced, or if you want to contribute to the P5JS community, you can always do that as well. There's this contribute page. And yeah, I think that's pretty much it. And for as I've demonstrated earlier, like earlier in this in the maybe the first session, if you want to share your sketch like this one, you can share it full screen like so, and then you can share this link to anyone, and people can even use it on their phone, and it will still work. So that's everything from me. Any other comments before I stop recording, or if there's anything that if you like to say and say a few more words after I stop recording, that's also fine. Are there any questions or comments or anything that you like to feel free to let me know.
Not a question, but just wanted to thank you so much. Really enjoyed it.
Yeah, thank you, Aya. Thank you, Yasman. Yeah, thank you.
Jack, instead of using the video from your camera, can you load in video the same way you loaded the image?
So loading a video, yes. Again, let's go to the reference. So instead of create capture, we also have create video. And then when you load it video, create video, and then it start with assets / that's because they create a folder called assets and then put the video inside. So you can use create video, and then but this, what's different, a little bit different is for video, you need to create this what's called a fallback function. Essentially what happens is after the video is loaded, this function is going to run, and this function, what this function does is you can use this function to loop the video. What it does is play the video. Once it ends, it starts again, and you can adjust the volume and everything. Once these are done, I believe you can just use image as a, okay, let me just to make sure. So this, you see how here it creates a video tag, a video element. So kind of similar to what capture did. It created like a separate thing that's outside the canvas. But you can use, but with that, then after you have the video, you can then use that, in this case, the vid. You can use vid variable and then use the image function to draw that on the canvas. So it's very similar to capture. The difference is that you load the video and then use the separate function to control how you want to play the video. And then the rest is pretty much the same. Use this vid variable and draw it with image. So as the video play through, the corresponding frame will be drawn on the canvas. I can share this link over here. Any other questions? Well, so this is a wrap. Thank you so much. Thank you, everybody. Thank you all again for attending the workshop. And I hope our roads will cross, and I hope we'll see you one day, maybe in person. Let's keep in touch on Instagram or via email. And maybe we can even collaborate on projects one day. Again, thank you so much.